That's it. That's it. We start. So, right. Good afternoon, evening, morning, wherever you may be in the world. Welcome to IETF 125 DTN Working Group Session 2, our second session for the first time. So I'm really hoping you're familiar with the note well by now. If you're not, please try and find a copy and read it through carefully. Fundamentally, this covers IPR disclosures, best behavior, and the fact that all public statements, recordings, and video are freely donated to the public domain via the IETF. Please check the privacy statement and make sure you are happy with what's happening. If you are not, there is an ombuds team who can also help you with any complaints and conduct. So to repeat what has been said in previous sessions, conduct guidelines. Please be courteous. Please understand that people have different views. Please understand that people may be working with English as not their primary language. So please try to, for native English speakers, please try and control the pace of your discussion so that others can internally translate and digest. And there is an ongoing team within the IETF to handle any complaints or measures, who we would suggest are the best first stop for any complaints. Meeting tips. I'm assuming you have managed to get onto Meet Echo. For people in the room, it is important in order for us to gauge how many people and how many chairs we need to have in each session going forwards that you have scanned the QR code and you are connected through using the on-site tool, even if you are sat in the room and enjoying all the audio visuals. That is mostly for our own internal accounting so that we can understand how large a session and how big a room we need for next time. For those of you remote, please try and manage your audio so that we don't get a lot of echo, a lot of side chat, etc. And to save on bandwidth, if you could kill your video when it's not actively in use, that would be really helpful. Headsets, again, strongly recommended, but in these post-COVID days, I think people are pretty good at this sort of stuff these days, I hope. So, these are the links to the data tracker page, how to get into Meet Echo, and how to report any issues. Adam, you are currently driving the shared notepad, but I strongly recommend that people also check what Adam is typing, add adjustments, corrections, because things can happen quite quickly, particularly around the correct spelling of names. Because people obviously say their own name nice and quickly because they say it a lot, but for others trying to pick up and type it into Meet Echo, just some corrections there are always helpful. Mailing lists.
Yeah, you'd think that I would be able to spell people's names with my last name. No.
No.
Help.
It is surprisingly tricky. DTN mailing list, and if you wish to reach out to the chairs, dtnchairs@ietf.org. Please subscribe to those lists. Useful discussion happens on those lists. So, our agenda for session 2, we have quite a packed agenda, so we're going to try and keep it reasonably tight. I didn't set a timer for myself, so I have no idea whether I'm already overrunning. Not yet. So we've got 10 minutes on COAP, we've got some BPSec information, and then I am presenting for about half an hour. I will try and keep that really quick on a number of things. Then Eric is going to cover a bit of BTPU, and then we have what I think is quite important is a 20-minute discussion on a proposal BIS for RFC 4838, which I think is overdue, and Ed will talk about that at some length. And we've got a quarter of an hour for open mic or to crash into as we overrun on the agenda. So, would anyone like to bash this agenda, make a suggestion, make any changes? Now is your chance. Otherwise, we will switch across. Go ahead, Ed.
Sorry, just one last thing. I've asked Scott Burley if he would take the 4838 BIS discussion because he is the one who's the primary editor on the BIS draft.
Okay, perfect. Perfect.
I'm happy to do that.
That's even better. It's good that Scott knows he's doing it rather than just being told he's doing it. Excellent. So I think we'll move swiftly on to COAP. I believe. Adam, can you find the slides? How do I? I'm a slide idiot. I'll stop sharing these slides.
Oh,
New deck is being
okay.
shared. Yes, I had to click permission and stop sharing.
Okay. Let's see.
And then obviously just to note for those who are presenting, because we don't have anyone at the table presenting with the clicker, just please let us know when to advance the slides.
And
Yeah.
I will monitor the queue and shout people out. If Carlos, for example, you're up first, can you let us know whether you want to answer questions during or at the end of your slot?
Either way would be fine with me. I don't know
Okay.
if you may have a preference. Yeah.
No, whatever the presenter prefers is my preference. Right, go.
Okay, thank you. So, hello everyone. My name is Carlos Gomez. I'm going to present the last update of the draft entitled Constrained Application Protocol Co-op over Bundle Protocol. My co-author is Ana Calveras, and we are both from UPC. Next, please. On the status of the draft, it was adopted right after Madrid, and today I'm presenting version 02, which aims to address comments received in the last IETF and also try to solve the last pending to-dos in the draft. Next, please. About the table of contents, we added a bit of new content in section 11, as we'll see later, and then we applied some internal structure within section 11, some subsections there, but the top level or main structure of the draft remains the same as in the previous version of the document. Next, please. So now let's go through the updates in this last revision. The first set of updates are in section 8.1 on co-op block-wise transfer parameters. You may recall that co-op block is an option that allows to carry out application layer fragmentation of large payloads. And we already had some content, in particular about one parameter, which is called max payloads, which indicates the number of consecutive blocks an endpoint can transmit without eliciting a message from the other endpoint. The main specification for block, which is RFC 9177, indicates a default value for this parameter of 10. And now we've added the content that is highlighted with the red rectangle here, which is that the motivation in 9177 for that default value is in turn based on RFC 6928's motivation for a TCP initial window of 10 segments, which reads as follows. 10 segments are likely to fit into queue space available at any broadband access link, even when there are a reasonable number of concurrent connections. We've added that, however, the previous statement assumes typical internet characteristics and TCP segment sizes. So now we're dealing with co-op over BP in this document. And for co-op over BP environments, the characteristics of the paths and the co-op message sizes involved will need to be considered when setting max payloads. For example, a deep space environment running co-op over BP will not necessarily have the same characteristics as a terrestrial wireless sensor network running co-op over BP. If you have any comments on that, please let us know. Otherwise, next, please. So then in section 11, which is about securing co-op over BP, as I mentioned before, we've added a little bit of new content, which is currently subsection 11.3. And we have also applied some internal structure with subsection titles. So 11.1 now has the title of DTLS versus OSCORE, but its content is the same. This is about the main options available for co-op to secure co-op. Then 11.2 is about OSCORE and BPSec, but again, the content is the same, nothing new in this part. And what is really new is 11.3, which is entitled Security Requirements of Co-op Requests and Responses over BP. And here, the new content is actually quite short. we state that when CoAP is carried over VP, a CoAP response should be protected with at least the same level of security as its corresponding CoAP request. And we are wondering whether this might be sufficient or not. Actually, a couple of days ago, there was a message with a few comments from Marco Tiloca, and he mentioned that about this content, possibly we referred to BP about how we should protect these messages, because DTLS and OSCORE have their own rules for providing the protection for responses, and we agree with that, and we plan to add explicitly, to mention that explicitly in the next revision of the draft. Next, please. Then in section 12.2, we have completed the content of an IANA request. Now that RFC 9758 is published, we would like to request the assignment of a well-known service number for CoAP over VP, and in particular in the IPN scheme URI well-known service numbers for BP V7 registry. So we have completed the content in this subsection, and also in a few other instances in the document that refer to this request. Next, please. And in section 14, which is about security considerations, you may recall that there is a risk when a node uses message aggregation, where the individual messages an aggregate message is composed of, those messages are called single messages. They need to carry the payload length option, which, however, is class U for score, which means unprotected. This means that an attacker might infer some features of the communication based on the payload size of the messages. And we received some suggestions in the last IETF that perhaps we might want to consider as possible mitigation using the new padding option, which is being defined in the cacheable score working group document, in the core working group. And in that case, it is possible to try some mitigation, which is that a single message would first be padded, and then the padded message can be protected with OSCORE. And the padding option is class E for OSCORE, which means that it's protected with encryption and integrity protection. And as a result, the OSCORE message would still have a visible payload length, but an attacker might not be able to know which part of the payload corresponds to padding or the original data. And then among the comments from Marco, he also mentioned that perhaps we might want to reduce a little bit the requirement level for this specific mechanism and cite this draft, the cacheable score draft, rather as an example of how padding can be added. And in this way also, this document could be cited as an informative reference, because currently it is being cited as a normative one. So yeah, we agree with that suggestion, and we plan to do that for the next revision of the draft. Next, please. So for next steps, we believe that the document is getting mature. We are not at the moment asking for working group last call, and we need to address the comments received from Marco, which are all important, but we believe that they are rather of minor nature. And on the other hand, since the document is now getting in this mature state, we would like to ask for reviews at this time. In the past, we've had a lot of feedback from both the DTN working group and the core working group, and we thank a lot everyone for the great feedback provided. And yeah, perhaps in the current state of the draft, it would be great to receive some additional reviews. So I believe that's my last slide. So yeah, thank you. I don't know if there may be any comments or questions.
Ed, go ahead.
Hey, I'm really glad to see the work progress. Question with chair hat off. Have we started to see any reference implementations of this with BP?
Well, we have we developed, meaning Ana Calveras, who's one of the authors, led she supervised a student who developed an implementation. The implementation complies with not the latest version of the document, but one of the previous ones. I think it's the last one before getting adoption. Now also other people are taking that work, and they plan to continue the work, like to update the implementation to the current state of the draft. The implementation is publicly available, and yeah, so that's the only one I'm aware of. I'm not aware of other implementation efforts.
Excellent. Thank you.
Thank you.
Okay, if there are no other questions, I have a final statement. For Carlos, thank you. Could you share the link to where that implementation is so that people could grab it and try it themselves or contribute or whatever? If
Sure.
that's okay.
Sure, I will do that right now. Yeah. And
Thank you. Thank you very much.
Thank you.
Excellent. Right, let me try and grab some slides because I think I'm next. No, I don't want to manage the slides. Adam, can
Or
you do
not
the
next.
magic, please? I'm being an idiot.
Yeah, I've noticed. You are not next.
I'm not
This is
next. It's Baggy next. Thank you.
Can everyone hear me? Fine.
Yes.
Loud and
Yes.
clear.
Audio check complete. Would you like to take control of the slides? Adam, do you want to pass the magic token? There we go.
How does one pass the magical token?
There is someone has asked to share slides. I'm clicking like mad. Nothing is happening.
You know what? I'm not gonna give. I'll do the
There you
thing you did before. Okay.
Okay,
Can I
perfect.
start? Okay. So my name is Bhagya. I'm a postdoc at King's College London, working with Benjamin Dowling. Now today I'll give a quick presentation about our SBAM draft. Starting with a quick recap, because we have changed it quite a bit since the last time we talked about it. So a quick recap. So SBAM provides specific end-to-end security guarantees, integrity guarantees between a BPSec bundle source and a BPSec payload destination, while preserving the BPSec default behavior, which allows intermediaries to process and discard blocks, including security blocks. The integrity guarantees SBAM provides applies to the security operations a BPSec bundle source adds to a BPSec bundle at origin. And SBAM design allows a BPSec bundle to maintain a verifiable record of all these security operations, even after an intermediary has processed and discarded the security block that contained these security operations. Next slide, please. So in order to provide these additional security guarantees on top of the existing BPSec design, we introduce two additional behaviors to the BPSec design, namely reporting and auditing. For auditing, we require the original bundle source of a BPSec bundle to add an authenticated record of all of its security operations as part of the BPSec bundle. This authenticated record, we call the auditing record, will contain all the identifiable information per each security operation the bundle source adds to the bundle at origin. For reporting, we require any intermediary that processes and discards a security operation that has been added to the bundle by its original source to replace that the block they process and discard with a record, an authenticated record of the identifiable information for that security operation. So the idea is whenever an intermediary processes and discards a source-added security block, then there's a record of that for the benefit of the final payload destination of that bundle. And a payload destination that receives a bundle that contains these auditing and reporting information will need to correctly verify them. And if they can't do that, then they'll discard the bundle. So next slide, please. So when we first proposed SBAM a while back, we required new distinct types of blocks in order to implement our SBAM design, which was not ideal. But recently, Brian got in touch with us about this new draft for a manifest block, which kind of perfectly aligns with our design for SBAM. So we have rewritten our SBAM draft, incorporating the design for this manifest block within our SBAM design. So with that in mind, we propose two different structures to facilitate our auditing and reporting functionalities. So for auditing, we propose this structure called an audit pair, which internally is a manifest and a BIB calculated over the information inside that manifest. The manifest block will contain the audit record that the BPSec source adds to a bundle at the beginning of the bundle creation. And the BIB will verify that information using a key the source shares with the payload destination. And this is created once at the beginning of the bundle creation and verified at the end when the payload destination receives it. Next slide, please. For reporting, we also propose a secondary structure that is also similar to the audit pair in that it is also a manifest and a BIB over that manifest. But this manifest will contain the identifying information for any security block and intermediary processes and discards that has been added to the bundle by the original source. So these identifying information again will contain things like block ID, security context information, and key identifiers. And unlike the auditing record, which is mandatory because for SBAM, because a bundle that payload destination that receives a bundle without this auditing pair will discard the bundle. But for a reporting operation, it is only added when an intermediary processes and discards the like a security operation added by the bundle source. Next slide, please. So within our SBAM design, we have a very kind of a heightened requirement for unique key identifiers because we build this kind of reciprocal trust relationship between sources, intermediaries, and bundle destinations. And for that, we rely on them being able to correctly authenticate these auditing and reporting operations. Within the BPSec specification, as it currently stands, local security policies define keys to use for the security context, which unfortunately is somewhat nebulous and not specific enough for the requirements within our SBAM design. Because the possibility of colliding key identifiers will impact the correctness of our execution. And because if the participating nodes cannot identify which keys to use for the authentication, this may result in our execution not being able to function correctly. So to kind of prevent that type of scenario, we do require the key identifiers to be included within the auditing and reporting pairs as a byte string. And we'd like your opinion as to whether this is feasible and your general thoughts on this. Next slide, please. One last thing is because of the way we have designed SBAM, it adds some overhead to the existing BPSec design, because every time an intermediary processes and discards a security operation added to the bundle by the bundle source, then it is replaced with a report pair, which internally is a manifest and a BIB over it. We wanted to get your opinion on whether this is feasible or can be is acceptable within the limitations and the capabilities of existing infrastructure. An alternative to this would be appending a special type of manifest, which kind of, instead of replacing every security operation with a audit pair, you can maybe internally expand this manifest every time an intermediary processes a security block and an operation. But again, we're not sure, and in that case we will require a MAC tag over every like data type, data map inside that manifest to authenticate the information. But again, we're not sure from an engineering perspective that this is feasible if one is better than the other. So in general, would really appreciate your opinion on that. Next slide, please. So that's pretty much it. We have completely kind of rewritten our draft. So please have a look at it and let us know what you think and what should change and yeah, what is missing and things like that. So that's pretty much it. Thank you so much.
So, Baguette, I'm in the queue because I've got a question, and I'm really glad Brian is in the queue as well. So, if you go back to, I think it was slide 5 or 6, you were asking about the key ID in the security context. Now, this is something I'm really keen on because as part of my BPSec interop, it's really annoying. Brian has suggested to me that for RFC 9173, the symmetric interoperable security contexts, that really worrying about key ID is a bit pointless because it's not really, I mean, symmetric key crypto, meh. But with COSI context, the key ID is carried in the COSI data, so it doesn't need to be added as a security context. Brian, I know you're behind me in the queue. Do you want to answer that question? Am I right in my assertion? Because I'm still unpicking this.
You are correct in what you stated. There is, I think, a slightly different need in what is presented here for the SBAM, in that the key IDs here don't need to be used necessarily for a key lookup as much as they need to be used to correlate and verify that the nodes themselves agreed with each other.
So they're definitely key identifiers, not so much as a key identifier that can be used as the key for a lookup. Okay, but they're sort of serving the same purpose. So I think this answers the question that you have on this slide, which is, do we need a key ID as a security context parameter? Brian's suggestion to me for the same question is no, if you use COSI. And my question, therefore, to the working group, chair hat off, is, are we happy to say 9173 probably won't work with SBAM because of this weakness? It's really for interop testing, and the COSI is the way forwards.
The only thing I would say to that last is that you still, I think, can use this with the default security context. It's just that whatever key IDs go in there aren't going to be conveyed in the data of the blocks that are being audited.
Okay.
And my direct comment was on the last question about needing to use pairs of blocks. To me, that's actually a benefit of this mechanism because you are reusing BPSec and all of its diversity and not trying to do something additional and special.
Yeah, that makes sense. Thank you.
Season, go ahead.
Hey, Season here. Hey, thanks, Bagya, for the presentation.
Thank you.
So I think the last point about the keys being explicit or non-explicit and working with the default security context versus a COSI context might need to be addressed, because I think what we mean here when we say, if we can go back to the previous slide, it is that the if we don't have it specified, that your correctness in even running this protocol may be in jeopardy. And I think that's something that should be hammered in here, because if you just rely on the implied fact that certain participants in the network will just know which key IDs to use, I think that may be silly, and especially if you're trying to also catalog, or in our case, the our record block here, the particular operations and which keys were used for what. So that's my comment.
Go ahead, Ed.
I had two quick things. One is I was really happy to see that we had migrated over to manifest block here. Thank you so much for that. The second is I do see the manifest block definition and behavior recreated also in your draft. My guess is that at some point we would want to separate those and maintain them not in the, individually, not maintain them individually, just have them be in one place. And I apologize for not having given this a clean read, and so this may be a question you've already covered here, but it is a manifest block per security source, or is the manifest block meant to only be applied at the bundle source? What is being manifested?
So we have two separate use cases for the manifest block. So at the beginning, the bundle source adds a single manifest block plus BIB combo, which is the audit record, and that manifest block will internally contain a few like data maps per each security operation it adds to the bundle. And also we have the report pair operation, which every time an intermediary processes and discards a security operation, then they also add a manifest block plus a BIB pair, which we identify as a report pair, and that is per intermediary that processes a security operation.
Oh, good. So I did hear that correctly, and then agree with that approach. And then just a +1 on Brian Cepos's point of keeping that as the diversity of BPSec seems like the right approach. So thank you so much.
Thank you.
I'll quickly jump in with chair hat on. If we felt it was important, and this is following on from Susan's comment, that a key ID as a context argument was useful, because it was something that would be expected by an SBAM participant, then the SBAM draft can request an IANA allocation for that specific thing. That is an extensible registry. Extra security context parameters, if I've remembered the name correctly, can just be defined, and as this goes forwards as a standards track document, if it was to be adopted, that would be a way of introducing this without requiring everyone to implement it everywhere.
Okay, yeah, that's good to know. I think we will continue this conversation over the mailing list. Thank you so much.
Perfect.
Yeah.
Thank you very much. Yes, now I think it's me. Sorry, it's fine. I will catch up time on this because I have 10 minutes to talk about Echo. Which
Rick, you have 3 in a row, 10, 10, 10. Would you like 3 10-minute timers or 1 30-minute timer?
Can you give me a 5-minute to start with? Because I'm going to do Echo in 5, and then I'll do 10, 10, because I think the last one is going to take longer. So I will I found out where the grab the slides button is. Take back control of the. No, take back control, and then.
Yes, I'm free.
You're free. I've got it. Okay, BP Echo Service. So this is the world's simplest draft, driven by conversations I've had with various people. Fundamentally, to say, shall we have a well-known service number for the Echo service, so that all of us who are implementing BPAs and various DTN stacks have a default which we can send ping packets to and expect it to come back. That's where this document started. Sorry, I should start on this slide. As I started to work through the exact behavior and semantics for what an echo should do, so I'm not particularly talking about ping at the moment, I started to dip into what do we mean by echo. So that's the second bullet here. I have defined a simple reflector that lives on that well-known endpoint. The purpose being is so that you can ping it in order to measure round trip times and connectivity verification and all the things you use IP ping for. This is the bundle protocol equivalent. Let's ask for a service number and a point actually going back to Carlos and his co-op draft. What I have speculatively done here is, again, I'm asking for an IPM service number from the well-known service numbers record, but I've also asked for a DTN demux, and this is an open question to the working group, is whether that is a valid request or not. This is an individual draft. I'm going to ask for working group adoption on this because I think it just needs to be done. So without too much to do, yeah, I've covered a lot of this. This is a repetitive slide. So fundamentally, the Echo service, it receives a bundle and it sends it straight back to whoever it received it from. So literally clone the bundle, do whatever memory copying you actually want to do according to your implementation and how your implementation does bundle processing, swap the source and destination, and then send it back. Important things to say about send it back. This means go through the normal bundle processing pipeline. So go through whatever ingress security, firewalling, packet filtering, bundle filtering you may have on ingress. Do the swap. It is effectively a service, although it feels a lot like a loopback device that does that very simple swap, and then push it back out through your normal egress for your BPA. There's no special source, there's no shortcutting. It is absolutely testing whether ingress plus egress works on that BPA so that normal traffic routing, filtering, shaping that you may want to be testing by running this ping is actually performed. The Echo service itself does absolutely minimal processing. This is quite important. So yeah, I have requested a port number. 128 is the current lowest. I'm happy if CoAP gets out the door first to have 129 or 150. It doesn't matter. There just needs to be a well-known number. Of course, that doesn't mean you have to use the well-known number, just like source ports or just like ports in IP land, in TCP and UDP land. You don't have to use the well-known port. It's just there if you don't need to specify a custom one. And the second bullet here is I suggest that /echo makes a good demux for a DTN service. I'll take questions at the end if you don't mind, because I'll just blast through this. I've got too many slides on this piece. A 7 has historically been used. I have no reason to stop 7 being used, but it happens to be in the private use space. So important thing about what this reflection does. It literally swaps the source and destination EIDs. It does not change the creation timestamp or the lifetime. This allows clients to measure full round trip time, and it also stops the bundle. It stops the Echo service having to invent a lifetime that it really doesn't have any clue about, because there's no real communication happening here. So if the ping tool sets a lifetime of 10 minutes, then the total end-to-end transmission is effectively 10 minutes. So really, it's not a response. It is a literal reflection with mutation. Everything else is unchanged. All the extension blocks, all the bundle processing control flags, report to EIDs, all that funky stuff is absolutely preserved. But you must recalculate the CRC because you have just manipulated the source and the destination. Payload and extension blocks. Yeah, don't do anything that you wouldn't normally do. It's very simple. No special features here. Hop count, previous node, bundle age. Do your usual thing. So if the hop count is 1, by the time you've reflected, you won't get the result back because it will have decremented hop count according to 9171. Standard behavior applies. If you are trying to ping simultaneously from multiple clients, you need to have unique endpoint IDs. This kind of doesn't need to be said, but this allows different ping paths to be multiplexed. So if you are using bibs on the primary block, or using bibs in general, do not include the include primary block flag, because the primary block will be manipulated when it is reflected, and your bibs and your BPs and your BCBs will no longer be valid, and security filters will discard them. And do not fragment. You don't need to fragment this stuff. Must not be fragmented, should be set. If you want to do path MTU testing, we're going to have to work out how else to do it. In fact, actually, want to do path MTU testing, you do want the do not fragment set. So there we go. Yeah, the usual security considerations associated with ping. This is an OAM tool. There's all kinds of things you can do with this. Be sensible. This is a NetOps administration consideration. You really should be careful how you run pings within your network. Probably shouldn't expose them externally. There is some boilerplate text in the draft. And I have added an appendix, which is some guidance, non-normative, for how one might want to write a ping service. Some hints and tips in there for how to make it work much in the same way that IP ping that we know and love. It's best practice stolen from the IP world and ported across to BP so that we can get some nice stats out and all that kind of stuff. I recommend reading it. And I have interop tested this. So my implementation has an echo service that implements this, and I have tested it against the DTN7 Rust ping tool, the HDTN ping tool, and the DTN ME ping tool, and they work without modification and without realizing that you're using my echo service, and vice versa works. So my ping tool, which thinks it's using an echo service that meets this spec, will actually run without modification against the existing reflector or echo service that is implemented in these three implementations. The reason I haven't tested Ion and Micro DTN is because they don't support TCP/CL v4. So there we go. That's pretty much it. What else have I got? Questions for the working group. Do we think this is appropriate? I think it is useful, just even if we just get the number. We can argue about the exact details of reflection and what a reflection means, but I think it's really important to have a number. DTN DMAX? That's adding a column to that IANA registry. That might be something we push back on and say we don't really know what DTN DTN EIDs really are beyond the 9171 description, so perhaps we should hold off on that. Extra security considerations are probably things to add. That's it. I'll take the cue. Go ahead, Scott.
Just that the security coming back on the echo is necessarily going to be different. The bit is going to be different because the primary block is different and the hash is computed over the primary block, so it will not be the same. So I think that's a doable thing. You can work around that with one of the provisos that were on one of the earlier slides. I think it's cleaner in a way to simply echo the payload and leave everything else just as here comes a block coming back and with an extension block that says where it came from. But I would be a little concerned about the special case with at least security. And parenthetically, I also think that the new tech, the DTN DMUX is also a fine idea. I think it's for a reason to do that.
So can I just respond about the BPSec piece? Yeah. BPSec, there's some really nice properties as a ping tool. If you can put a signature on something and say, I expect to see my payload to come back unmodified, it gives you a certain sort of idea that, oh, actually, there are things along the path that are actually accepting BPSec. You could almost do some BPSec level pinging to check that it gets through filters correctly. As long as you say do not include the primary block in the generated ciphertext that goes into that block, which is a perfectly valid flag option, then you're absolutely fine if the primary block gets manipulated. I
would be worried though that there would be some networks in which that wouldn't work because it would always be mandatory to protect the bib, the primary block with the bib.
I would suggest that's an operational challenge, and in those cases you probably say don't put bibs on. This is, as I consider it, this is an internal network operations and management tool that you would run within your network, not try and run this across the solar system internet at scale, much like ping tool doesn't really leave administrative domains or local intranets.
Okay, thanks.
Yeah, no worries. Next up, Eric. Oh, Brian, sorry.
Yeah, I see definite value in a payload or ADU echo as an interop minimum. The other echoing, I can see as being trouble, and that's all.
What I'm trying to do is to say, don't change anything. Change what is the absolute minimum you have to change to make this work. So effectively it does do payload echoing, but it maintains the total lifetime and the hop count. Actually, it doesn't maintain the hop count. The hop count is just decremented. But yeah, happy to take that to the list.
Okay,
Eric.
sure.
On the point of adding a DTN demux column to the honor registry, I think that makes sense to me. I'm in favor of that. The only thing is, I think grabbing common words might not be great, and it might be better to have underscore IETF / or .iona / or something as a prefix.
Okay.
Just so that future work doesn't conflict with terms somebody might be using.
A fair point. And that's kind of the can of worms about a DTN demux, and I'm very happy to push that out to when we actually tackle the DTN EID structure as a whole, and just go for an IPN well-known service number for now.
Yeah. Thank you.
No worries. Felix.
Yeah, thanks, Rick. I think this is really something extremely useful because it's used all the time when we set up testing. But I think in your draft, you are really mixing two different concepts. We discussed in the past the simple ADU reflection, which for me is kind of fully in line with the RFC. It means you receive an ADU, you put this ADU in a new bundle. You don't reflect this bundle, you put it in a new bundle. You do the transmission, you do all the steps you do to normal bundles. And I think this is something quite simple to standardize and put forward. It also gives you information about the processing a node is doing to usual bundles. And you kind of toggle between these things. You say it's all the usual processing of the bundle, but then you say, okay, but we keep some extension blocks. We might do a little bit here. So I think what you are having here with a reflection is something where I really have difficulties to describe it in terms of the RFC 9171, which may be shortcomings of the RFC 9171. But I don't see a really clear way to describe these things you're proposing here conceptually. And I also see some real difficulties, especially with the creation time, which is giving, really, we have clear rules on creation time, who's providing the creation time. And now we have another node basically just copying something over. So it seems to be not a very clean way to do it. So my question would be, shouldn't we go forward and define a simple ADU reflection, have a well-known service number, and understand the use cases for the reflection better to understand what we need to put into place to have this reflection mechanism? Last note on the interoperability testing, I assume the interoperability testing, you get a bundle back, but I'm really wondering whether it fully implements the behavior we are specifying here, especially in terms of extension blocks and creation time.
So yes, I am absolutely sympathetic to saying just reflect the payload. I completely understand that. The reason I have touched on creation timestamp is because if you enable status reporting, which is quite useful, and I know it's default false, but this is an admin tool. If you disable status reporting, you would actually like all the status reports out and back to go to the same report to EID. And in order to correlate the status reports, you need to understand that the creation timestamp maps to, ironically, now the destination rather than the source, so that you can correlate these status reports into one sequence. That's the reason for not changing the creation stamp. If the echo service on the far end creates a new creation stamp, then you get status reports sent to you, and you have no idea why they're being sent to you. You have no idea which ping, and you may have multiple pings in flight, this status report corresponds to, unless you want to go into the ADU. And that, I'm happy to have that discussion on list. So simple is best. So I'm happy to start removing any of these suggestions to cut it down to really simple. Ed, go on.
Yeah, Chair, all comments, Chair hat off. A few things. I like the idea of the service. I actually see value in both kinds of reflections. Perhaps it would be helpful to have a use cases or an expanded use case in sections of this in the draft. I had one specific question. I just couldn't see it as I was skimming the draft itself. If I send an echo request to you and you only switch the IDs and send it back to me, how do I determine that the thing coming back to me was the echo versus something sent to me so that I need to echo? It seems that there would need to be some signaling that says this is a reflection back and not a independent request from someone else that I myself now need to echo. And I don't know how we avoid those reflections.
Because your and this is written in the appendix, the how to implement a ping sensibly non-normative section. It says your ping source EID should not be the echo service. It should be some ephemeral number, so that when the source and the destination are swapped, the response message comes back to you as the service, not to the echo. Otherwise, you end up with an endless reflection.
Which makes sense, and I missed it. So thank you.
That's fine. If there's no one else, I will move on to the next, if that's okay. Adam, please do your slide magic. The battery in my mouse is dying.
Okay. What do your ARP next, right?
Yes, please.
Yes.
So this is part of Rick's series of filling in small holes in the road that we kind of need to make BP run sensibly at scale and cover those bases. So let's request access to the slides. Yes, I want to take control of the slides. Perfect. So this is BP ARP, which looks an awful lot like IP ARP and does pretty much the same thing. So fundamentally, there are CLAs, and I'm looking at LTP here, and maybe applies to UDP, but I haven't read the V2 document in enough detail to define this. And definitely, I'll start with those two, which do not have a mechanism in band to advertise the node ID of the other end of the peer. So the remote peer. So you get a CLA connection, you get a link, you know I can pass bits of bundles. In fact, I can pass whole bundles between two CLAs, but I actually don't know who the next hop neighbor is to do anything smart in terms of setting up my routing tables. To set up, oh, I understand that that guy down that CLA is actually this EID. Unless it is pre-configured, I don't stand a chance. And that is exactly the hole that this is trying to fill. So here are some examples. There is a second example here as well, which is Bundle Protocol has two different addressing schemes, the IPN EID scheme and the DTN EID scheme. TCP CLv4 only allows you to advertise a single node ID. So you normally pick which one you want. IPN is kind of the de facto at the moment, which means you have no way of advertising, oh, I have some other multi-homed addresses effectively. I have a DTN node ID as well. So this also is a second feature of this ARP protocol, is to allow a peer to say, actually, I also have this DTN EID that I couldn't tell you across this CLA link. Next slide. There we go. So I've pretty much covered this. The way it fits in is it's kept to very limited. It will do the, I have a CLA adjacency. Let me learn the node ID, and then I can hand it off to whatever more complex two-hop neighborhood discovery I'm doing, or I can correlate it to some sort of contact planning I'm doing. So it bootstraps SAND and other things, and it only does this one piece. I'm not trying to replace SAND. I'm not trying to cut into the early stages of SAND. I'm literally trying to say, I've got a CL address. I need to map that to an EID so that I can then bootstrap everything else. It only works with singletons. There's no multicast business here. You give me your singleton node IDs. It starts to break down if you go multicast. This is not IGMP. This is the equivalent of ICMP. This is a BPA service. You are asking a BPA what its node ID is. So therefore, in my mind, that's an admin record, and you target the administrative endpoint. So you're not asking for the echo service for what it thinks. It's EID is. You're asking the actual BPA because you want the node ID. It only requires a single admin type because you can tell whether it's a request or response because I introduced the local node as a destination, and this is a change. So, and these bullets are a bit strange order actually. So the IPN only probe mechanism, you have to use the IPN scheme in order to use BP-ARP, although you can learn about DTN or other schemes. Well, multicast and anycast aren't supported, but you can learn other schemes via the IPN scheme bootstrap of ARP. So you must support IPN. Protocol flow, this should be really simple, but it hides a little detail which I should have drawn out in its own slide. So node A knows the CL address, but doesn't know node B's ID. So it composes a BP ARP request, which it sets its source as the admin endpoint, because this is a BPA to BPA conversation, and it sends it to IPN exclamation point .0. Now, for those of you who've read the IPN update RFC, that is the local node address. So local node has some restrictions, which is it, as written in the IPN update, is not allowed to leave the local node. It allows one service to address another service on the same node without having to know the node's node ID. I am slightly abusing this to say, whoever receives this message, this is for you, which is a slight variation, and I've got a slide which talks about this in more detail. So that is received by node B. Node B replies with the response, setting its source to its one of its node IDs. In this case, it's the IPN node ID because this is an IPN-based conversation, with the destination back to the source that sent it. That's it. The receiver then can it can see the source of that response, and B, it can read the payload, and I'll talk about the payload format in a second, and therefore perform the discovery. Very simple, one exchange. Hop count equals 1. This is meant to be one hop. This is meant to be linked local. Do not route this, and you do standard protection. I can't remember the name of the acronym, but it's a fairly common behavior in IP to control one-hop propagation of IP packets to set the TTL to max, and therefore detect that it won't increase. In BP land, you set the max hop count to 1 to prevent it going any further. Also, it is a direct CL transmission. You are specifically saying, using this convergence layer adjacency, I wish to probe, I need to send this bundle to the other end of this link. So don't go through the RIB and the FIB lookup. Don't start using your contact graph. Literally poke it down that CL hole. So again, that's another reason why it's very much an administrative BP native implementation detail. This can't be an external service. It's got Delta query support, so you can say, I know you've got this node ID. What other node IDs have you got? Which allows you to bootstrap off IPN and learn DTN node IDs. And you should use BPSec bibs in order to authenticate that you are actually who you say you are, particularly with, if you're using COSI context, you can start to assert your certificate with actual key material which maps to your node IDs, and you can put some proper security on the whole process. That's a should, because I cannot make you do it, but you really should do it. So this is the critical change. So this updates 9758. So 9758 says there is this concept of local node, and local node must not leave the local node. So any bundles that come in addressed to local node must be discarded, and no bundle destined for local node, they must not leave that local node. It was just an absolutely blanket security policy, basically to say these are local, these make no sense on the network. I am proposing to loosen this to say, if you receive a bundle and it's an admin record, and if you want to put type filtering on it and it's a BP ARP message, then actually IPN local node exclamation point is allowed for this specific case. Other destinations discarded, all previous rules apply. Okay, so it doesn't open local node for general use. It literally just cracks the door open a little bit for this case. The alternative to this formulation is we go and register a well-known IPN node ID in the default allocator in the IANA registry for this specific case, and it is a non-singleton EID, but it's not an Anycast EID. It's a very specific magic number, which means a bit like naught means nowhere. It's another magic number. And I am proposing that we should use the local node because we've already got this magic number, which is 2 to the 32 minus 1. Alternatively, we can go away and register a new magic number, and that's an open question. I see Felix in the queue. Felix, go ahead now, actually, if you don't mind.
Yeah, so because it's exactly on this topic, so I'm wondering why you are not considering using the IEC Anycast naming scheme for that, because this has the idea of kind of well-known groups, which basically would say any node. And you wouldn't have to do these tricks with the local node or the additional naming scheme or whatever. So because I'm a little bit worried, we are putting on all these kind of small exceptions everywhere across the, let's say, BP world, which makes it quite difficult to understand. I think it's a typical use case we would have for Anycast.
Frankly, because I started writing this before I read the Anycast draft, I'm very happy to use a well-known Anycast group ID. I think that makes perfect sense because you're exactly doing this. Someone who is a member of that group, and this is all nodes would be a member of that group if they support BPARP. So yeah, that's a very sensible suggestion. Very happy to make that change.
Yeah, it seems we need to put this Anycast personal draft into the working group draft soon, and I'm happy to work on this. Yeah.
Okay, let's pencil that in for a topic for Vienna, and we can sort of between us all collectively get that moving if that's all right. We'll check how Camillo is going with it. Okay, so security considerations. Go on, Brian. Did you want to say something?
I was just going to say that I am in big favor of any mechanism to address a neighbor non-specifically, and I'm definitely in favor of that. And maybe decoupling that from the payload would be helpful.
Yeah. Okay. Use BPSec with very simple stuff. There's some security considerations. I suggest you read the document. They are basically be sensible. Be aware that this is revealing information. Use BPSec. All the usual stuff. And also there's some recommended on what a BPA should do in terms of configurable policy. So a system administrator can say, actually, I don't want to turn this on for some things, or I don't want to turn it on for my box. Yeah, IANA considerations, new service number, please. Yeah, so the open questions I kind of covered on the way. Is there interest in adoption? Are people interested in the Delta query semantics, the ability to say, I know one node ID, what other ones have you got? We've kind of talked about local node, SAND. I'm not touching SAND. I'll let Brian talk about SAND. He has already, but I'm not trying to do SAND. Are we happy to have this as a separate or bring it into SAND? I think you've kind of answered the first question, and I will stop. Ed, go ahead, because I know I'm overrunning, and I said I wouldn't.
No, you read my mind. So just chair head on. We have eaten through much of what would have been our open mic time. So I would just say let us proceed and then try and keep to the 10 minutes for the next two topics.
Noted. Thank you. Right, Adam, can I have the next slides, please? Boom. So next topic, and this is going to be challenging, I think. I can see people having questions about this, and my stock answer will be following from Ed's comment. Let's take a lot of the debate to the list. So, DTN peering protocol. Let me request slide access. Okay, so this is my attempt to solve the problem that you have two independently administrated DTN domains. So let's say, and this is purely for example purposes, but something everyone can understand. NASA operates a load of DTN enabled stuff, and ESA operates a lot of DTN enabled stuff. Now, NASA and ESA in this example want to share information about how they may use each other's relays to deliver useful science from space to ground. But of course, NASA doesn't want to allow ESA to manipulate the internal routing of the NASA network and vice versa. So how can we have a mechanism where ESA and NASA can agree to share the relaying capability of their individually managed domains such that relaying can occur? Because of course this is a store and forward system we're building. That is the problem space. So in order to do that, you need to have, and there are too many slides here and I recommend you read it yourself. There cannot be a single global contact graph. We have to understand that there is a separation of administrative control between these two domains. And what we can do for two domains, we can scale to n domains. And it should be a single mechanism that supports all of it. Now, those of you who have been around the IETF for long enough go, ooh, this feels an awful lot like BGP. And yes, this is BGP for DTN, with a couple of little tweaks based on what the world has learned about BGP since it was first invented. So, and I'm going to blast through these slides for timeliness, but because there are 19 of them, but there's some useful properties in here. Key design principles. Okay. It is transport agnostic. So it actually runs over gRPC. And the reason it runs over gRPC is there is a separation, and it's the final point, between DPP speakers and the gateways that transit the bundles. The idea being that whatever NASA is running to manage its DTN network and whatever ESA is running to manage its DTN network is on the ground. And these two back-end systems can have a terrestrial back-end conversation about the gateways, the relay points, the transit points that may well be in deep space. But the ground system knows where these things are because it's their assets. And that is a reality at the moment. I'm not going to touch on what happens when we're all living in bubbles on Mars. I will be retired and that will be somebody else's problem. For now, I'm trying to solve the easy problem, which is big orchestration systems sat on the Earth are allowed to talk to each other about transit gateways that are off Earth. So we can use gRPC, which is great, which means we can be transport agnostic and we can just get the code running nice and easily. But in order to do this, we need to unify the IPN and the DTN schemes into a single way of doing prefix no, my brain's gone dead. In order to do longest prefix first matching, because this is lifted straight out of BGP, so that we can work out which routes are more general or less general, so that we can work out a prioritization between them. And we do that in this document. The other thing we need to determine is exactly whether the person who was saying, I know where the ESA transit routes are, is actually ESA. So there's got to be some identity. And the way I'm asserting this identity is I'm using DNS, because DNS is also terrestrial. And remember, we're talking about on the Earth at the moment. So that means you can do all the good stuff with DNSSEC, and you can start looking up cryptographic material in DNS and start to assert identity that way. So therefore, you can separate who I am from where and what I can route. That's quite an important consideration, watching the time on this. So speakers and gateways, read this slide at your own speed. Everything else, for those of you, and this is a nice diagram explaining exactly the same thing. So a DSN would have a DPP speaker speaking to another autonomous region, which would be ESA. Two speakers hold the session. They talk about gateways that manage the routes, and bundles travel between those gateways and off to the spacecraft. Nice, simple architecture. DNS-based identity. Okay, so you publish an SVCB record of the DTN domain on your DNS name that you own because you are a large organization who manages spacecraft and can therefore afford to get a DNS domain. And you can publish your public key and the algorithm you use in your public key into that DNS record using DNSSEC to assert it, so that when two peers in DPP need to assert identity, they can do a DNS lookup, check the keys are valid, and therefore use that as part of the key exchange and the key agreement hello mechanism that's described in the protocol doc. Yeah, and this is the handshake flow for it. So you do your DNS lookup, you issue a challenge, you get a response, you do a verification on the cryptographic primitives, and therefore you know you're there, and then you can start sharing records. So after you've done that establishment, as long as you're happy with the lifetime of the cryptographic material, you don't need to constantly do it. You've got an established session which you can trust. Obviously, you're using gRPC, so you'll be using TLS, won't you? Everything else is pure BGP. So it's BGP updates, it's distance vector. You've got a list of hops for loop avoidance. So you can understand that in a multi-domain environment where you've got ESA, JAXA, NASA, or private companies, Intuitive Machines and Rocket Labs involved in this or whatever, you can work out that you're not going round in a big loop by bouncing ESA, NASA, ESA, NASA, ESA, NASA constantly. That's what distance vector gives you. There are metrics for administrative preference, which is pretty much the MED from BGP, if people know MED. The root prefixes, and I haven't clarified this enough, are EID patterns. And I think on the next slide I come into that. So the EID patterns I have simplified to say there can only be a wildcard at the end of the pattern. So you have a fixed prefix, and then you can say effectively star. So it is a strict subset of Brian's EID patterns specifically for root sharing. So I'm not trying to say that Brian's draft is, or it's actually a working group document now, is invalid. I'm saying for the root sharing part, we need a stricter subset, which is what I talk about here. Extensible attributes straight out of BGP. Things which get stripped hop by hop, things which maintain, all the kind of valid stuff in here. There's a bit of TVR has crept in, so valid from, valid until. So you've got contact windows as well as forwarding, so you can advertise a future contact and do your scheduling that way. Sorry, I'm trying to condense a very large slide. Specificity scoring. So this is how you map both DTN EID patterns with wildcards and IPN EID patterns with wildcards down to a single numerical number you can compare to work out whether one route is more specific or less specific than another route. Because if you look at the underlying BGP rules, which I've kind of copied across into this, specificity scoring is how you determine which routes override other routes or duplicate or mask routes. So there is a basic algorithm for reducing EID patterns down to a score so that you can compare them correctly. I'll let you go through that in your own time. It's a little bit complicated. So here we go. Route selection, very simple. Highest score, so prefer an exact over a wildcard. Fewest hops is the second. Administrator preference metric is third, and the oldest route is better than a newer route to maintain stability. Of course, local policy can decide what it wants to do, but these are the general rules. I am going to stop now because there's going to be a lot of questions and I have a lot more slides, but I'm conscious of time. Does anyone have any questions on this, or have I just baffled you with 19 slides of deep detail? The draft is now on the data tracker. I had to wait until the window opened before I could push it because I was still churning it until quite recently. Go ahead, Brian.
Thanks. I think using DNS to assert some ownership is a good strategy. And I think there's enough detail in here to be able to start picking over those details as a draft.
I recommend people grab the slides off the data tracker, read the slides, and then go to the draft because there's quite a lot of content in here, and the slides give you a pretty good overview. And on that note, I will shut up. Thank you for your patience. I yield. Ed, take over.
No, no, I was just going to say thank you, Rick. And then I think it's Eric for BTPU, Ethernet, and quick convergence layer. And Eric, do you want to share, or would you like me to flip slides?
Do you mind flipping slides? I'm inside Chrome on an iPad. I don't know.
Oh, yes, indeed.
What that would look like.
I can absolutely do that. So these look promising. Can we start here?
That's the cubicle one, not the Ethernet one. We can start with that one if you'd like.
Well, sorry. There we go. Let's start with that one.
Sure. Thank you. And you can put 10 minutes on for the two together if that's okay. Thank you. Yes, so this is the latest version of BTPU over Ethernet. If anybody hasn't read it, it's basically requesting some Ethernet properties from IEEE and from IANA to allow transmitting bundles directly over Ethernet for links that don't have IP configuration and for other Ethernet and Ethernet-like links. Some of which is in the document. I added a reference to the fact that you can have Ethernet bearer sessions in 3GPP, and also that the US Space Development Agency's optical terminal specification uses Ethernet, although if memory serves, in a slightly unusual way. So originally I had tried to think about replicating all of the UDP CL semantics over Ethernet, but then along came BTPU. Next slide, please. It has all of the required issues sorted. It's got multiplexing and segmentation, and it has FEC support. Draft 04 is out with a bunch of updates responding to feedback from Brian, principally, I believe. And I added a little bit more Ethernet security stuff. We talked about virtual channels. How do you identify one stream of Ethernet BTPU packets from another, including how that applies to the MAC address. And I reordered the sections based as well on Brian's feedback. Next slide, please. So I think this has been around for a little while. I think it's actually it's ready. It's beyond ready for adoption at this point. Probably ready for last call. I don't know what else is missing, but I'll just leave that for the group. The document is informational. It's very short. Just requests the IESG to authorize talking to the IEEE to request an ether type, and also to talk to IANA to request a multicast MAC address.
Yeah, Chair had on. We can certainly take that to the mailing list. Also, Brian.
Yeah, I'll just mention that I think this is a necessary part of proving out BTPU. So it's a good thing and a needed thing.
Great, thank you. And that's all for Ethernet.
I had a quick question or a quick comment.
Yes, please.
Yeah, so the quick protocol here, being a convergence layer adapter for bundle protocol, if it's purely being used over the motivation being like traditional comms, is there still consideration, or terrestrial comms, is there still consideration for then using this over space links as well, like space link to space link?
Okay, so you're on this this presentation now, not the Ethernet one. Your question is about quick.
Yeah, quick as a BP convergence layer.
Yes, there isn't any reason why you could not use the quick timer adjustment work that's being discussed in TipTop to control how the quick CL behaves. If that's where you're heading.
Yeah, I guess so I have an active, or we try to propose a draft in there as well to address the security concerns with the handshake mechanism in Quick, which uses TLS, and we were trying to we said that there are some issues with essentially using that synchronous type of handshake mechanism that Quick uses to establish a secure session in these kind of DTN environments. And if it's going to be used as a convergence layer adapter for BP, then we have the same issues again, except now magnified for most of the BP uses for deep space. So that's one of the concerns that I would have with adopting it like as is, and perhaps considering asynchronous style connections instead.
Okay, I'm not coming to it's not coming to mind exactly what it is you're referring to security wise. I probably need to go find it and read it.
I'll put a link in the chat and maybe move this to mailing list then.
Okay. Yes, Ed.
Oh, sorry. Just to address the or question about that point with Quick and the security part of it. Certainly see how that's an issue if it is only a Quick layer. But if Quick is the CLA underneath and you are running a bundle layer that is getting and applying BPSec for and different keying strategies at its layer, does that does not relax your concern about the Quick security issues?
I think that actually is a little bit duplicative. You would then have two different keying services. I guess you'd have to choose one over the other as to which particular keys to use. Do you want to use the ones that were established by Quick, which is a like session-based style using ephemeral keying information over the links, or do you want to use the ones provided through Quick or through BPSec, which isn't through the default security context at least isn't specified.
Chair hat on for a second, because I'm conscious of time. Eric, can you get further through the presentation? Because I think this might answer some of Susan's questions, because it should describe some of the use casing. And
yeah, I don't know. I'm happy to actually get to off of slide one.
Yeah, this is a longer discussion, and Susan, I absolutely understand your concerns, and I think these should be addressed carefully at length on the mailing list. And yes, I absolutely want to address these because a lot of them are applicability concerns. It's like if you use it in these cases with these sort of round trip times and delays, then you have a lot of these concerns. I think, in fact, I know what Eric is proposing is a fairly generic mechanism, and we'll get into some more of the specialization in later revisions. So, Eric, go ahead, please.
Yeah, I must also admit that I had principally had in mind here terrestrial relay as well, and I had thought that some of the tip-top timer adjustment might be suitable for other deployments, but yeah, I think maybe I should, for the interest of time, skip past what Quick is. If you don't know what Quick is, here's a list of RFCs. It's a UDP-based transport. It has a mandatory TLS. It's got some anti-ossification properties that the DTN community hasn't probably worried about for a while. It has both reliable and unreliable datagram delivery, and it has multiple streams in the same connection, so there's no head of line blocking. Next slide, please. So I know there was some other work to propose a quick convergence layer, but this is a very short document that just tries to provide a very straightforward mapping of bundle transfer mechanics to Quick semantics. It basically says for reliable transfer, just one and only one bundle per stream. You get transport layer acts that confirm transport layer delivery. Just to hang on a point here for 1 second. It's not the same thing as agent-to-agent delivery. I think we actually need a separate agent-to-agent message to confirm one-hop delivery. Obviously, it supports multiple simultaneous streams, and there's basically, you're never going to run out of streams. It's also possible to use unreliable datagrams if you want to, if you're somehow, for some reason, not worried about dropping them. And the document says you should just use BTPU in that case. Notably, the document requests an ALPN for use in the TLS handshake, and it also requests an adderleaf _QBCL for use in DNS service discovery. Again, principally for environments where DNS works, terrestrial mostly. Next slide, please. And yes, because the intent here is to get to this place where, thank you, yeah, slide 5, where you could have a Mars-orbiter .example name that you want a delivery for. And you can do the standard _DTN bundle lookup in SRV that's already specified. and get an SRV record that points you to Cloud Agent here, or you could use the service binding RFC 9460 lookups to underscore qbcl.mars over to get a reference to this other information. And there you can find a service binding record that will give you all the connection parameters you need to bootstrap a quick connection straight away. Get the port number, confirm the ALPN as qbcl, get some IP addresses, and away you go. So there's and that's basically the end of it. Yeah, I'm out of time. So there's one more slide, but not yeah. Oh, if we do actually get an IPN.ARPA, then it will also be possible to take an IPN number, put it into an IPN.ARPA form, and then just look it up directly, get a CNAME to ars.orber, and then begin to do all the same lookups kind of thing. So that's sort of where this is headed. I think this will make terrestrial delivery quite easy to discover things without having to have a lot of manual config, but it's all just sketched out. Anyway, the document requests these parameters. So I think that's out of time for me. Thank you.
All right, Eric, thank you so much. And last, which will be a quite a summary, is just going to be a short presentation. Scott, happy to flip slides if you wanted to work through this to talk about the existence of a 4838 biz and some of the things that are on our mind for that.
Sure. Very briefly, I think this is like only 5 slides. The most important one probably is this one, the motivation for doing an RFC 4838 biz, which is there are some concepts that have evolved over the last 19 years since 4838 came out, and it's worthwhile to document those changes. But I think more important than just the desirability of keeping up to date is that as tolerant networking becomes more broadly used and adopted in spaceflight operations, more and more people are tending to become interested in it and want to know something about it, and will look for a document that tells them what this is all about. And if they pick up RFC 4838, they may get some confusing information that is different from the way the protocols work now. And it would be good to bring the architectural overview into alignment with the protocol definitions. So let's go to the next slide then. I think what we've got here is a summary of the rationale for the DTN architecture, and I think most of these things are items that we've discussed a lot over the last couple of decades. There have been some rethinking, and the next 3 slides, I think, summarize that rethinking. There are things that are retained. We think these are still as true as they were in 2007. Next slide, there are some things that may need to be reviewed, revised, removed. And all of these would be, of course, fun to talk about right now, but we don't have time. And then next slide, I think these would be additional concepts that are significant enough that we ought to present them to people who are looking for information about tolerant networking and belong in that introductory document, which is really what we're trying to do with this architecture draft. And again, these are all like interesting things to talk about, and we'll have to do it later and on the mailing list. And I think I should stop right there and ask if there are any questions.
Scott, thank you for that. And I would just chime in, Chair Hat, on exactly what you said at the beginning, which is we're getting a lot of interest in DTN. We have more than filled 2.5 hours at this IETF. 4838 is a thing that comes up quite readily when people search for DTN. Having an update to that is going to be an important thing. So let us take some of this to the mailing list, and please keep it an active conversation there. Eric?
Don't just say thank you and goodbye.
We are done. Thank you. Thank you, everyone, for a really packed 2 sessions.
Thank you all for your patience. Thank you, guys. See you in Vienna.
Bye.
Bye-bye.